and I work as a front-end web guy there. And tonight I'm going to tell you about this hobby that I have, which is called Elm Native UI. So let's just quickly get a show of hands. How many of you have used Elm before? Wow, that's a lot. Cool. And for those who don't know, Elm is this super nice and simple functional language that compiles to JavaScript. How about React Native? How many of you have used that before? Okay, a fair amount of people. So React Native is a toolkit that enables you to basically write native quality mobile apps using React. So that's basically writing JavaScript to make actual native UI components on a mobile app. So it's not like you have a hybrid application, but it's actually using native UI components. And then there's thing called JS Core that's running your JavaScript code, and that's the bridge between the native components and your JavaScript code. So how many of you have heard about Elm Native UI before? Wow, still a few people, nice. So if you work with React Native, you probably recognize this thing. So we kind of thought that this is many times just because it's so hard to JavaScript. Because JavaScripting is actually really hard. It's so unsafe and so fragile that you just end up in these weird things called unexpected token or something. So we tried to make that better. We were at this conference in last November called Reactive 2015, and many people were asking whether you could actually use Elm to build React Native apps. And me and Andre were thinking that, well, Andre knows React Native and I know Elm, so we could make it happen. And less than a week later, we had this small button pressing proof of concept, which was here. Incredible. But it got quite a lot of likes and retweets, so we thought that, well, this might be something that people are interested in. So a friendly chap called Paul Young, he's not the singer, but a designer from California. He showed up and designed a beautiful logo for us. And then it was basically quite quiet for the next 2 months or so. So then I wrote this blog post about it. And it eventually led to me talking with Evan Czaplicki on how that thing could be made better. And he actually said that the things that we were doing so interestingly with the ports and stuff, those could be really simply made if he made just a tiny little change in the Elm compiler. And then he showed me how to do that, and that's what we've been doing since. So this guy called Josef Napora showed up, and with his and Noah Hall's and my own work, we got the whole thing working on main. So we got it working like regular Elm applications, which was really nice. So at that point, I figured that it's at a point where we could actually try and publish that as an Elm package, but since it's running on a custom compiler, we weren't actually going to publish it yet, but at least I refactored it so that it can be installed as a self-published package nowadays. And a little later, these two guys from Berlin were at this Elm hackathon, and they tried to use Elm Native UI for something, but they realized that there was only the text, view, and image components. So yeah, they needed to do something about that, they felt. And then they came up like uh, a month later with a generator script that scrapes the documentation of, or actually the source, how the React Native documentation is generated. They scrape that and turn that into Elm code. So that was pretty cool. Uh, so that basically meant that all the other components could also be used now. And just last weekend, we were at this CycleConf with Oscar and Yanni and some other people. And we had a lot of fun with Cycle Native. So using the functional reactive way of doing things in Cycle.js and building React Native things for that. And we managed to get animated and navigation working on that. So I have a small demo about that as well. So these are all coming from HTTP, and there's the navigation. It's a fractal architecture. And then there's the animation. So yeah, I think these are some of the learnings that I'm going to put in the Elm Native UI as well. So did I have a slide about? Yeah. So we made this stopwatch application with a work friend a couple of months ago, just to learn how to use Elm. And this is the thing on a web page. So this is like a basic Elm application. So on the flight over here from Helsinki, I decided that I'll try and make this into a mobile application. So that's what I did. I'm just gonna show you first the regular old one. So on the left, you see the code, and on the right, you can see the actual application. So as you can imagine, you can start and stop, and you can reset, and you can set flags. Okay. So on the code side, can anyone see this code? Okay. So you have the actions here, and well, here's a helper function for the time formatting, and let's say the models are here. This is like a bit hacky code, but still update function. And let's see some view here. So there's the divs, like a div has a div as a child, and that has two children. So pretty basic stuff. And that same code migrated into native UI. Looks like this. So we have the actions, the same helper functions, the same models, same updates. Basically, everything is the same except for the view functions, and those are like in a really similar fashion. So you have views, which are the equivalent of a div, and then you have the text elements, which are needed for React Native to pick up a text node. But otherwise, it's like exactly the same. The biggest problems that I had was that since React Native is not basically styling with CSS, it's CSS-like DSL, basically. So the styles that I have here have been all migrated to the React Native way of doing things. And since this is a statically typed language, we can actually make statically typed CSS as well. So let's say border bottom width, it's a number. So if I make that into a string, it's going to complain that it's expecting it to be a float, but it is a string, and so on. But yeah, you're probably wondering if it actually works. I'm also wondering if it's going to work this time. But let's see. So React Native run iOS. It's doing a lot of stuff. Starting the packager. Hey. So we got something running. I'm going to dismiss this for first, but well, I'm going to come back to those. So as you can see, everything is basically in its place, but doesn't look quite right. Everything works. I can add the labs here, and I can stop it and start it, but it doesn't look right. And that's what the warnings were. So there's like a shit ton of these. Invalid prop style key color supplied to view. Because who would want to set a text color on a view? It only needs to be on the text node. So this is something that, like, I don't know how to solve, if it's even possible to solve it like completely, but React Native has this interesting way of styling things, and it would be really, really nice if our static typing could actually like warn you that this should actually be on another element here. But for now, it's like you can set whichever styles you want on whatever element, and it will be allowed, and then the React Native app will complain about the things that you did wrong. But yeah, it works. And it's basically the same code, but only the views have been changed. So back to the presentation. So what's next for this? Well, the future, in my opinion, is bright, but it's a little uncertain. Elm 017 is just around the corner, and it's going to change a lot of things. So we're going to basically have to rethink how we do all the interfacing with React Native. But on the other hand, it should actually make the whole thing a little easier and less of a hassle. And then there's also the thing that React Native updates every 2 weeks. So they also make some breaking changes every now and then. So we need to figure out a way of maybe we just lock it down to a certain version and then be done with it, or I don't know. Or then we just wait for React Native to be more stable as a platform. But yeah, that was basically it. I'm Hanhinen on Twitter and on GitHub, and these are the two most useful links for you. So the first one is the actual Elm Native UI repository, and the second one is the application that I showed you. So and before I forgot, I also have some stickers with me. Any questions or comments?
So can you explain a little bit more about what you have to change in order to keep up to date with the latest React Native versions? For example, I mean, are you writing the Elm interfaces by hand, or can you generate those?
Yeah, so as I said, the Berlin guys made the generator script. So basically we could just rely on that and just regenerate all the definitions for the components. But I am certain that there will be some other complications as well. And really, I cannot say which ones or. Anything else?
All right, thanks again, Ossi. Really good talk,
Thanks.
thank you. So next up we have Lewis, who's going to be talking to us about PureScript. So I'll let you set up and then kick off. Thanks.
Screen button. Yeah,
Green one?
Yes, yes. Just entire screen. Yeah.
Desktop?
I think so, yes.
Yep.
Oh, is it like entire screen?
I can share my drawing everything together because I have some code out, so.
Yes.
So so what is being streamed, the presenter view of that one? Yeah, because I'm not used to PowerPoint, so I want to mirror the screen. So do you know what to do that on?
So yeah, you're getting presenter view.
Try a slide. So Oh.
Is this what you want?
Okay, I want to have both things in the same place.
Oh, okay. I think for that you need to switch the screen mirroring, maybe. Just to, yeah.
No. Any extra on PowerPoint? Because right now I have something different on my screen, and that's what is being screened. So that will be really weird for the people that is trying to watch this. So, do you know how to show the same thing on my screen and on the other one?
Same thing, you want to do the same one?
Yeah, because if I start the presentation.
No, go to display. Click on Apple. Yeah, go to operating system preference. Go to display. That's it.
Yeah, no, it's let's do something. That's okay. Okay. So, shall I start? Yeah. First question. How many of you have heard about PureScript? How many of you have used PureScript? Okay. That's going to be interesting. So my name is Luis. Well, my name is pretty long, but call me Luis. And I'm a software engineer at William Hill. And disclaimer, I'm a backend engineer. So what is a backend engineer? Talking about a language that compiles to JavaScript. And my first contact with this language was like a year and a half ago. You know about Amazon Lambda? So I wanted to try Amazon Lambda. So I went there. I was so excited. And then suddenly I realized that I had to use JavaScript. And sorry, I hate JavaScript. Not only I hate JavaScript, but it's JavaScript on top of Node.js. So the worst combination for me. So I was really sad because I was working as a data engineer, and having a serverless architecture that can consume events when they happen and process them was really, really powerful for what I was doing. So, but I couldn't try it. So I was waiting for the JVM version. I tried the JVM version, but I had to upload a jar file of 30 megabytes because I'm a Scala developer. I'm a functional programmer. I use Scala. I use Haskell. And I had to upload 30 megabytes files just to execute one single function. So I decided to try this language, PureScript, because it compiles with JavaScript, so it might be easy to use in Amazon Lambda. It was possible. I did a talk last year about it, but that was my first contact about PureScript. So I don't know that much about front end. I have done front end, but I have an example of an application later. And I use Bootstraps, sorry, because that's what we backend guys use when we want to do front end. So, but I should start saying that don't try this at home, but that's not true. Try this at home, at your friend's home, or everywhere you want, because PureScript is an amazing language. And it's a language that is Haskell inspired. And if you have heard about Haskell, probably you know all these bad press that Haskell has, but Haskell has a really nice things. And all those good things are in this language. And this is a language that compiles to JavaScript. And because it's a Haskell-inspired language, it has a really powerful type system that allows us to build really complex, powerful abstractions that makes our code simple, easy to read, but really powerful. And also because it's compiled to JavaScript, it also interop with JavaScript in an really easy way through the foreign function interface that the PureScript has. And what do you use to build PureScript applications? Well, the standard toolset for any JavaScript application: Node.js, npm, and Bower to handle the dependencies.
But on top of that, you need the PureScript compiler, and you can install it using npm, like with that line. And when you install PureScript, you get a plenty set of tools. You get the compiler, PSC bundle, that is something that discard all the dependencies that you don't really need and create a single JavaScript file that you can upload to npm. So if you want to create a library using a PureScript, PSC docs that allows you to create the documentation from the source code, and then you can publish that using PSC publish to PureScript Pursuit. This is like a really cool interface where you can download browse the documentation of all the modules or probably all the modules on the PureScript ecosystem, but also you can look functions for using the type of the function. If you know that a function affects an integer and a list of something and returns a string, you can type that, and hopefully you will find the function you are looking for. There are also some tools like PSC IDE server and PSC IDE client that allow you to use Atom and any other editor that supports those tools as an IDE. You get all the big goodies like autocompletion. You can browse and navigate the code, and all that for free when you install the PureScript distribution. And also, one of the coolest things is the PSCI, the REPL, because when you are starting to learn a language like PureScript, you want to try things. And instead of having to create a full-blown application, you can just load the REPL, the read, evaluate, print loop, and try things. And for some of the examples, that's what I used. And the other tool that you can use Gulp as well if you want to, but most of PureScript developers use Pulp. Pulp is a front end for the PureScript compiler that, with the init command, creates like a scaffolding of a project with test folders and basic tests and source folder and everything. You can build your application either as a set of folders with all the modules or as a single file that you can distribute. You can browserify this if you want to run this in the browser, because if you use build, even if you create a single file, it will not run in the browser. And then you can test, you can generate the documentation, you can run your application, or you can run a server if you want to try that the application served from a HTTP server. So you don't need anything else to start to play with the PureScript. And what is PureScript? It's a language, a static type language. So you have types. And the core PureScript only have like 7 types. 3 of them are JavaScript types, numbers and strings and booleans, and 4 of them are PureScript built-in types that are not supported by, are implemented in PureScript in the compiler. Integers, arrays, records. Record is the way you map objects, JavaScript objects, into the PureScript world, and functions. And all this is inside something called a module. If you know Elm or similar language, this is pretty similar. You have a name for the module. In this case, this is copied from the example. This is a component. It is the module that contains a registration form. You can export part of the module. Like here, I only export in the registration effect, registration query, the initial registration state, and the registration form component, or you can export everything. You can choose what you want to expose to the end users. And then you can import other modules. Either you import all the module, like import prelude, or you import only the things you need from that module. Because if you import everything right now with the latest version of the compiler, you will get a warning. Because probably that if you have too many imports, you can have conflicts with the names of the functions and everything. So it's better not to do that. But also, if you want to really import everything, you can do it as a qualified import. Like this example, when you give a name to the module, and then every time you want to use something from that module, you have to use that prefix. That way you avoid collisions. So you can choose either import everything through a qualified import, or just import what you need. And PureScript is a pure functional language. What that means, everything is an expression. Everything is evaluated to a value. Example here, I run the REPL, and a number is an expression, but also adding 1 + 1 is an expression, because the plus operator is a function. is defined in the standard prelude as a function, and it uses something to combine the numbers. So everything you have in PureScript is an expression. It has to return a value. It's not like in imperative languages where you have a statement, and that statement can do side effects or whatever, and it doesn't have to return a value. So we have to return always values. In Elm, it's the same. But sometimes we want to give a name to one of the expressions. We can define, we can have something that is called a definition. For example, 42, we can create using let because it's the REPL. It was created in a file. I can avoid the let. And I'm creating like an alias or giving a name to that expression. And we also have functions. Here we have the add function. We are adding two numbers, like pretty standard. Any functional programming language, you can create function this way. But if you see these functions in PureScript are codified by default. What codification means that functions are not functions that accept a set of parameters and return a value. A function is something that accepts one parameter and returns another function that accepts another parameter and returns the end value. That means that we can do partial application. For example, here we have the add function, and we want to add 2 to any single number. So we create another function that is called +2. This is the add function with the first parameter fixed. Then we can use +2 to add 2 to 3, and we get 5. So if you don't know anything about Haskell, you can probably say that, okay, this is Haskell. I'm not learning anything new. But there are some differences with Haskell, and I don't know that much about Elm. So this we are starting to talk about things that I don't know how they are mapped to Elm. But sometimes you have functions that you don't care about the types. You have functions that they behave in the same way, no matter if your parameters are integers, strings, or booleans. And that's what in PureScript we call quantified types. For example, we have this function that given 2 parameters, one of type A and one of type B, it returns a parameter of type A. And just by looking at that, you know that the only thing that this function can do is to return the first parameter. Is this useful? I don't know. But at least just by looking at the types, and that's why I like PureScript, because you have types and the types guides you. If I had to, somebody told me, okay, this is the definition of the function. You have to implement that. There is only one thing I can do, return the first parameter or just go home and not implement the function. But as everything is an expression, there are no loops, because loops is a construct you have in imperative languages to iterate and do things, and they need mutability. And PureScript is a pure function language, and there is no mutability. But we can implement loops using recursion. For example, we have the create common denominator function, and I can implement it this way. Either we have the 2 base cases when I stop and return a value, or I call the same function to iterate. But this way of writing this function is a bit ugly. I'm using a lot of if, else if, nested, and it can be a bit hard to understand. There is something else that's called pattern matching. So we can say, okay, if the second parameter is 0, return the first one. The first parameter is 0, return the second one. If the first parameter is lower than the second, and this is called a guard, do this recursive call, and if not, do the other recursive call. So this is more readable, and we are using this feature called pattern matching. But this is a language that compiles to JavaScript. So at some point, we have to interact with JavaScript. And when we are interacting with JavaScript, we want to pass data around. And we have data types that are JavaScript types, numbers, booleans, and strings. But what do you want to have? An object, because we want to pass a collection of values to JavaScript. We have something called records. The translation of this to JavaScript is a JavaScript object. So there is no cost, not runtime cost, when you are using this. But it make it nicer to use all these collections of properties, because we are defining here a type alias. This is a user, name, surname, age. It can be a user that is registered into a website. And we can use that as the type of our functions. So we can create a string from a user this way. you see that the accessing the properties of the object is the same as in JavaScript. Or if we are a bit lazy and we don't want to repeat the user dot whatever all the time, we can use pattern matching by giving a name to the name property, the surname property, and the age property. Or we can even be more lazy and using the same names of the as the properties, we can just do this. And then any way we implement this function, we will get a string. But I said I'm using a type alias. This is how it really looks like. So PureScript accepts anything that has a name property of a string, of type string, any property of surname, any property called surname of type string, and any property called age of type in, because PureScript uses duck typing, static duck typing. So anything that meets this contract will be accepted as a parameter of the function, because we are using a type alias. PureScript pushes this farther forward, and it has something called row polymorphism. Because imagine that we want to modify the age of this user. We can just accept a function that does something with the age, within an integer, accept a user, and produce a user. And this is the way you modify a PureScript object. You use the name of the property, and you change the age with a new value. But in the end, what we really want to do is to modify any object that has an age property and many other properties, like this R means I don't care about these other properties. As long as it has an age property of type in, I will accept that. And I will return another the same object with the age modified. And this is called row polymorphism, and is a really powerful feature of PureScript, because it allows us to create libraries that only focus on one property of the age and allow us to modify other objects that, as long as they have the same individual property. And also, we know how to pass objects back to JavaScript. But how do we use JavaScript functions? Because in the end, the PureScript is a new language. The ecosystem is small. There are not that many libraries. And at some point, we will need to use some JavaScript library, or maybe React or whatever. We use the foreign function interface. And what we do is assign a type to the JavaScript function. In this case, you have a JavaScript add function that, given two numbers, return another number by adding them. And what we do is to implement, either we implement that in JavaScript or we map it. But in the end, we have this. We have a function that adds two numbers. But you see that this is a weird way of writing a JavaScript function. This is a carified JavaScript function. Most of the time, we would love to write that function that way. Or most of the time, we have libraries where functions are built, are written this way, and we want to use that in JavaScript, in PureScript. PureScript has the function, data function and carried package that allow us to do that. We define a function of 2 parameters. Those 2 parameters are numbers, and we return another. And then we, using this run function, we corify that function. So it's not that you do this when you are writing your own wrappers around functions, but you can use this when you want to wrap something that already exists. And as a pure functional language, we are not allowed to side effect. That means that we are not allowed to display an alert box. We cannot write into the developer console. We can do anything at all. We can do it only if we use effects. But it's pretty simple to use. Imagine that we want to generate random numbers. This is an effect because from nothing we get a number. So we create an effect, the random effect. And it's created with you following with this syntax. So you don't really need to understand why is that. You just copy paste. That's what I did the first time I did it. It took me like a lot of time to first write my first effect, but it worked in the end. And then you have a function random that returns an effect that the effect is random and something else. You see that this is also row polymorphism. I don't really know if there are more effects in my program, but at least there is going to be a random effect. And then I return a number. So in the end, this effect is returning a number, and you don't really need to care that much about what is inside here, as long as you have this pipe effect, because the compiler will do a lot of magic to make sure that everything type checks. How do you implement the effect? This way. So I'm just calling math random. Pretty simple. But you see that I have here this function that has text, not parameter, but this is wrapping this, because the effect has to be lazy. If I just call math random, this effect will be executed immediately, and there will be some problems from the point of view of PureScript. But probably it will be easier to look at that if we think about, okay, if I generate a random number, what I'm going to do with that number? Let's say that we want to print that number. We can create a console effect that is wrapping console log. And this function now is accepts a string and returns an effect unit. Unit means it does nothing. It doesn't return anything. It's a pure side effect and doesn't produce any value. But it's a console effect. Again, we have the pipe effect because, okay, we know that if we use this function in our program, we are going to have more effects, but at least we are going to have console. The implementation is this way. Now this makes more sense why we have this empty parameter, this function with empty parameters. We accept a string, then we put this because this is the effect pattern. Every time we want to write an effect, we do this. Every time we want to wrap a PureScript JavaScript function, we do this. And then we print and return an empty object. That's unit. That empty object is what PureScript understands as unit, nothing. It's an object without properties. Then we can combine both things to generate a random number and print it. And suddenly you see that here, suddenly we have two effects. And that's what is called type unification. PureScript is really smart to know that we are using the random effect and the console effect. So the type of this function is something that uses the console and the effect and the random effect and maybe more things. And this is hard to understand at the beginning, but it's really important because everything that is built on PureScript, in the end, some way or the other resort to effects. Because in one way or the other, you have to interact with the outside world, and that outside world is JavaScript and the browser or Node.js, and that's done through effects. So just by copy pasting, you can more or less understand how it works, and then at some point you will really understand it and will create your own effects. But it's really, really quite easy, and there are plenty of libraries already there that you can use. And what you can do with a PureScript, apart from going crazy with types and abstractions and effects and monads and whatever, and all those weird words that pure functional programmers like me love. Well, you can build a form, a registration form, using this library called Halogen, that is like Elm for PureScript. So my idea was to build a simple form with some validation using PureScript. I learned this library at the same time I was building this because I'm not a front-end programmer. So this is the first time in 2 years I have done some front-end code. But it's actually not that hard, surprisingly. So you see, this is the common layout of a PureScript project. So you have a source folder with a main object where your main method is. This has to be an effect that returns unit because that's how PureScript wanted to have, wanted to be. And then the main thing here is that you define your user interface, and then you run your user interface with an initial state, because PureScript is a immutable. Everything is immutable, but you can have a state machine. This is like a state machine. You have an initial state, and every time something happens on the interface in Halogen, it changes the state of your app. So you can think about it when you are designing something like the registration form. What you are thinking is about what is going to happen with my form. Either they press the submit button, or they update the age field, or they update the name field, or they update the surname. And then when I'm defining my registration form, I have to define two things: how I render the form and how I interpret those commands, because there's like a state machine and a command and a query, an event is triggered, and I have to do something with that. And you see how the form, the rendering function looks like. It's pretty similar to Elm, the way you define web pages in Elm. So I'm pretty sure that this library was inspired by Elm. And what I have is something pretty simple. If we go back to the presentation, oh, sorry, this one. I have 3 text fields, a navigation bar, a submit button, and an error panel. You can see that here I have a form. I'm using Bootstrap, so it's responsive and all that cool things that everybody likes to do. I have 3 text inputs: name, surname, age. I have what is going to be displayed every time there is a change. This function is called because you have to update the form because there is a change on anything. And each of them is producing one of the commands. If I make a change on the text input, I create the update name event or command. The same for the surname, the same for the age, and the same if I press the submit button. And then what I have here is the error panel in a div. What I do when I get one of those commands, for example, if I submit the form, well, let's see that later. If I update the age, what I need to do is to modify the state to change the age. And there is a modify function. Forget about all the boilerplate, the do, the pure next, and everything. Focus on just this line. I'm changing the state. I'm changing the age of the state. The state is just something like this. It's the name, the surname, the age. All of them have strings because the input text are strings, and I don't know if they are valid or not. And then an array of errors in case I have some errors. So what I'm doing on all these methods is just updating one of those properties: the age, the name, the surname, and all the other stuff is just the things you have to do because you are using PureScript. But once I have everything, I decide to press the submit button. I receive the submit command, and I can get the state. And you can get either the state as an object, or you can use pattern matching and get the name, surname, the age, and the errors. And then what I have to do, I try to create a user object from this input. How I do that? I have a model. I have what I have here. Yeah, I have here a user registry. I'm using a new type, so because I don't want to pass any kind of record that has this property, I want a user. So this prevents me to pass anything. I can only pass a user. And then what I want to do is to validate that all those fields are valid, because I want to make sure that the age is a number, the name is not empty, and the surname is not empty. And you see all these funny symbols here. There are some methods, like proper words you can use, but I don't know them. I'm used to these methods in the Haskell world, so I use them. But what this really means is, if I have a non-empty name, a non-empty surname, and an age that is an integer, I'm going to call this function called fromValid that will create a user. And if any of these or all of them fail with an error, and the error is like property name is empty or property is not a number, I will collect all those errors. So if all of them fail, I will have 3 errors. If 2 of them fail, I will have 2 errors. If all of them are successful, I will have a user. This is called applicative validation. You don't need to know anything about that. If you read the PureScript book, PureScript by example, they will explain how this works in a really easy way. So you don't really need to understand category theory, functional programming, nothing at all. It's a pattern. You apply the pattern and you get all the errors. But when I have this, there are 2 options. Either I got 1 or more errors, or I get a valid user. If I have 1 more errors, what I'm doing is just updating the errors property and let my rendering function to display those errors. If everything is okay, what I'm doing is just logging the error, logging the user, because you can submit this to Ajax, to whatever, and create a user and move to a different page. But for this example, just logging the error, the user was good enough. And then you see that here I have plenty of helper methods because it's not this becomes too messy, too long, too really hard to understand. I have a text input method that creates a text input, just a div, a form group, a label, the input text. And I think this is the more important thing. What happens when I change a value? On PureScript, you can define a event handler this way. So when the value changes, I'm going to get the value of that input field and create this is a function that creates a query command. A query command is one of those. And you see most of them, except from the first one, all of them accept a string. So every time you change the value, we are going to take a function, wrap it as one of these commands, and submit that event to the event loop. And then my evaluation function will evaluate the command and do something. I also have a submit button. And what the submit button does is just, if I press it, what do you do when you have a form, a registration form? You prevent the default behavior because it's going to submit the browser and refresh the page. So you prevent the default behavior, and then you submit, because this is a command that has parameters, what you are doing is submit an action. The action is whatever action is this one in the case, but that's it. So this is again the most important part of this. What happens when you press the button? I submit a command. I inform my render event loop that something has happened. So this is event driven. And if there are any errors, I have an error panel here that this is probably this is one. If it's empty, I display nothing. If it's not empty, I display an alert box from Bootstrap with a list of errors. Probably a lot just to make this happen. So seems like a lot, but you know that if this compiles, everything is going to work because that's the powerful of a static type languages. And then if I type something like Luis here, now 2 errors, 1 error. I don't know how that, okay. So again, an error, 23, boom. And I go to console, boom, my user there. No, I'm 37. So yeah, if you want to learn more, you have this book, PureScript by example. The author is Phil Freeman, the father of PureScript. It's a bit outdated, but it can give you the basics to learn this language. And then you go to the IRC channel. People there is really helpful. Phil is always hanging there, and the other main contributors, and they are really helpful, and the community is also really helpful. And that's it. This book talks about monads, all those weird words that people are afraid of, but they do it in a very nice way. And so by the end of this book, you will learn all those concepts without realizing, and you will realize that they are just patterns, the ways you do things. That's pretty much it. You have any question? Yep.
So you were describing a bit ago the interaction with the JavaScript libraries, and in PureScript, you were actually basically explaining the behavior of the JavaScript function. So I accept, my input is going to be 2 numbers, and I will return a number. But in JavaScript, there's this funny thing in which my function might output a number depending on the inputs, or maybe I don't know, a string, or maybe something else. How you tackle that in PureScript?
Yeah, well, the authors of PureScript are really smart people. And when you know that the function might or might not return a number, you can have like, I'm not sure if that's called unsafe, but this might be a number, like a maybe. And then it's like a maybe a number or maybe not. So it's either a number or nothing. And so you can add that to the function and write the function in a way that will prevent that from happening. It's the same as in JavaScript, you have nulls. In PureScript, there are no nulls. So if something can be a null, there is a type called nullable. And if you suspect that your return type can be null, you say, okay, this might return a nullable integer. So you can use it in a safe way. So you can say, okay, is this a null? Yes, don't do anything with it. It's not a null, do something with it. And it's the same for other complex data types. For example, I send you a JSON, but you don't know if the JSON is going to be well-formed, it's going to be a JSON. There is something called a foreign type. I don't know what it is, but I give you a function that will transform that into maybe a user object. So this is all part of the language. Not the language, not the core language, but all part of the ecosystem. There are libraries that support these kind of things. So you can interact with JavaScript in a safe way.
What's the difference between a number and an int?
Good question. An integer is what we understand as an integer, a natural number. Not natural, negative, positive, with a range. A number, in JavaScript, there are no natural numbers. Everything has floating point number, a double, actually. So number can be 1.5. An integer is always 1. It cannot be 1.5.
Okay.
Thank you. I have a couple of questions. When you showed the effects, you showed that something called, you had the do notation.
That one.
Yeah. So you use something called log, but you specify console has type console. Should that be log instead? Like why?
It's log because the function is called log.
Oh, and you.
But
I don't understand why the lowercase. Why is that console?
Because when you define when you're defining the interaction with a JavaScript library that is performing a side effect, the first thing you define is an effect. And it's the foreign import data console. You see, this exclamation mark gives a name to that effect. It's like the type of the effect.
So it's just a convention that the type is the same name as the thing.
Yes, it's a convention. And then you see that I have console in lowercase because I have to give a tag, because it's it's like having a row, a record. You have to give a name to the property that represents that effect, and the type is the effect type. So I go back to records, exactly the same. When I define a record, I give a name to the property and a type. Name is the name of the property.
Yeah, but you're using the name, right? So username, so user.name. So for me to make logical sense, it should be called log. So log with the type of console.
Yeah, well, the type of log, once you pass the string, the return type is an effect.
Okay.
And you have a record of effects that you can never access. This is just for the compiler to keep track of the effects and reject. If somebody you want, because here you are returning more than one effect, and some function accepts any kind of effectful function as long as they produce console. Okay. But other functions will say, okay, I only accept console. So that's the way you say, okay, I'm performing this effect. It's like a way to keep track of all the kind of effects you have in your function, but you can never access them. So this is a convention. You could just not give them names, but because they already have all the records and raw polymorphism infrastructure in the compiler, so they use the same approach. So I think there was a ticket, I don't know how that ended, but they wanted to remove that name and just use the types, because it will probably be less confusing than just giving property names and like here console random. But this is just a convention. It's like this is actually creating a console and a random effect. The names are not important, and the log function produces the console effect. The random function produces the random effect.
Okay, thanks.
Hi, kind of further to that question, actually.
Yep.
When you were showing the example with the halogen, I think it was, it seemed to have a different effect type. It was like a.
Uh,
maybe that was just I missed
Sample,
it.
would you mean this main class?
Yeah, it's got halogen effects there.
Yeah, well, this is a type alias.
Okay.
This is a type alias that is an effect, and under the hoods you have a probably it's better if I go to the GitHub repo and I show it to you how it works. Because sometimes keeping track of all these effects is a bit difficult. So what you provide is alias for these effects. Okay, here it is. So the halogen effect is something that takes an effect and adds to it all these other effects, and I don't really know what they are all about. So on top of the effect, you are defining here. In my case, is the console effect. I have other effects, the DOM effect, because I'm going to manipulate the virtual DOM, the exception effect, because there must be extension might be raised, and the other effect that I don't have a clue what the other effect is. So this is a convention. This is like a type of constructor.
Okay, so the
My
halogen effect
others.
is a sort of superclass almost of the
because
normal effect.
In the end, when this is a type alias and it's the same as in here, you see that name, it looks like you have a user, but what you actually have is this. What is that? Sometimes it matters to you, sometimes it doesn't matter. But in the end, as long as what is under your control, that is the fact that you are passing to this, to this, as long as everything that is in here is fine, you don't really need to care about the others. You only worry about this effect. The other is just a wrapper.
Okay, thanks.
Well, thank you very much, Lewis. A really interesting talk. Thank you. So we don't have a date for the next meetup, but if you keep an eye on the meetup page and on Twitter, I'm sure it'll be announced soon. Stick around for a drink. There are more drinks downstairs, and hopefully we'll see you next time. So thanks again to our two speakers and to Skills Matter. Yeah, have a good evening. Bye.